This is lecture number 22 of the course AU 203 Statistics and Quality Control. In this lecture, we will talk about linear combination of random variables. We have already seen random variables. Now we will see how the linear combination of random variables works. And there is a property called reproductive property of normal distribution. We will look into that, and then we will go into solving problems related with linear combinations of random variables. And in the end, we will see into the sum and multiples of random variables, problems related with the random variables where we are dealing with sum and multiples of random variables. Okay, just look into a story of an employee. Mr. Employee just had one of those bad days. Everything went wrong. First, the school bus arrived 5 minutes late to pick up my little boy. Then it was wet and slippery, and there were so many people about that I just could not walk at my normal speed. Usually I take 15 minutes, but that day it took me 18 minutes to get to the work. And then when I got to the work, I had to wait 3.5 minutes for the lift instead of usual half minute. So instead of arriving my normal 10 minutes early, I was 1 minute late. So this is a story of an employee, and by hearing the story, employer's action is boss just won't listen his story, and he simply doesn't accept his excuse and ask him to leave. So do you think that his case is for an unfair dismissal? So what you need is, in this problem, let's say there are several variables involved. Let's say if we bunch together all these variables into a one single variable, we call it an arrival time of an employee. So he used to arrived at his office 10 minutes before the normal time, but and that particular day he was 1 minute late. So you need to look into the random variables which are involved in the arrival time. So try to pause this video and try to answer this. Okay, so if you see this problem closely, there are 3 times involved. Actually, the first is this employee had to wait for a school bus for his child. So bus was in that particular day 5 minutes late. So S is representing the time that he had to wait for a school bus. And then he has to walk to the work, and the walking time is represented by letter W. And then he had to wait for a lift to reach to the upstairs in the office, and the time to wait for the lift is L. So this arrival time is actually not just a single variable, because the time for school bus, waiting for a school bus, is a random variable, and how much time he takes to walk to work is another variable, and time he needs to wait for the lift is also another variable. So total arrival time would be a linear combination of sum of those 3 random variables S, W, and L. So this is an example of a linear combination of random variables. So here the time to arrival is a random variable, which is actually a function of 3 more random variables. So the distribution of these 3 random variables would be depending, and the total time to arrival would be depending on the 3 random variables. Okay, now look into the representation of the linear combination of random variable in the mathematical form. Let's say we have x1, x2, just like S, W, and L, there are different random variables involved, and a0, a1 are some constants, and their combination of the constant and the random variables linked together with an equation. We call it the sum of a0 plus a1 times x1 plus a2 times x2 lead to another random variable y, and we can say that y is actually a linear combination of the random variables x1, x2, and xk. As we already know that random variable is actually a function, each random variable is a function, so linear combination y would also be a function of x1, x2, and up to xk random variables. So if we are interested in calculating the expected value of the linear combination of random variable, here it is y, an expected value of y would be equal to the expected value of a naught plus expected value of a1 times x1 and expected value of a2 times x2 and so on. And from that we already have some rules for expected value. Then expected value of a constant is actually a constant, and expected value of a1 times x1 would be a1 times expected value of x1. So this is how we can write down the mean of the linear combination of the random variable. And the next thing is the variance of the linear combination of a random variable. Let's say if we have x1, x2 are the particularly independent random variables, so there is no dependence of the outcome due to the random variable x1 with an outcome of x2 or x3 or xk, then we call these random variables to be independent random variables. So then y would be a linear combination of these independent random variables. In this definition, particularly here x1, x2 are not just random variables but independent random variables. And then we can calculate the variance of these linear combinations. So variance of the y would be the variance of a naught, and since a naught is a constant, we know that the variance of a naught is actually 0, because the variance of constant is 0. And similarly variance of a1 times x1 would be a1 square times x1, that is the property of the variance. So using that property we can write down the variance of the linear combination of the random variable would be equal to the square of the constant times the variance of that particular individual random variable. So this is it is very important here in this definition of variance that we are dealing with independent random variables, because if x1 and x2 are not independent, then there would be a product term between x1 and x2. That term is actually called as covariance term. So once we take that assumption of independent random variable, then this covariance term will not be involved in the expression for calculating the variance of linear combination. So this is specific, otherwise x product of x1 and x2 would come into play. That is actually called as covariance. So we are not dealing with the covariance so far. Okay, so there is a property called a reproductive property of normal distribution. So let's say if we have a special case of x1, x2 are independent random variables, and these random variables are normally distributed. So each variable is normally distributed. So x1 is normally distributed with a mean value mu1 and variance sigma 1 square. Similarly, the x2 random variable is normally distributed with this. Then we can say that the linear combination of these random variables would also be normally distributed. So this resulting function would also be a normal distribution. So once your random variables are normally distributed, then if you form a linear combination of these random variables which are normally distributed, the resulting function y would also be normally distributed. So this property is given a name called reproductive property of normal distribution. So we can say that y would also be a random variable which will also be a normally distributed with the mean which we already have evaluated earlier. A naught a1 plus expected value of x1 would be mu1, and similarly the variance of x1 is sigma 1 square and variance of x2 would be sigma 2 square. So we can say that the resulting variable would also be normally distributed with mean value equal to this and the variance equal to this. So variance is not just sum of the variances, but constant square times the square of the standard deviation, which is the variance, and then take the sum. So that would be the variance of that random variable y, which would be normally distributed if x1, x2 are normally distributed. So, and we can easily calculate its expected value of the random variable y, which we already have seen it. Similarly, we can calculate the variance of that resulting variable, which will be a normal, which would be normally distributed. So this property is actually given a name called reproductive property of normal distribution, because random variables, if x1, x2 are normally distributed, then if you take a linear combination of those random variables, here it forms with represented with the letter y, that y would be a random variable, and which will also be normally distributed with the mean and the variance, which we already have explained. Okay, now look into the problems which makes better understanding of how to deal with the linear combination of random variables. Let's say you are manufacturing a part which is having a length and width which is normally distributed. So length could be normally distributed, width of this rectangular part is normally distributed, and the mean length is 2 centimeter and standard deviation is 0.1 centimeter. The mean width is 5 centimeter and standard deviation is 0.2. So we need to determine the probability that the perimeter exceeds 14.5 centimeters. So what is the probability that the perimeter of this perimeter is actually, as we already know that here width and length are random variable. Let's say we represent length with x1, which is normally distributed with mean 2 and variance 0.1 square, and width is also a random variable which is normally distributed with mean 5 and variance 0.2. So as we know, the perimeter is the sum of the length of twice of the sum of the lengths and the width. So it would be twice of x1 plus 2 times of x2. That would be y would be a random variable which would be the perimeter. So as given in this problem, that the probability that the perimeter should be greater than 14.5 centimeters. So we need to work out this probability. So as we know that using this reproductive property, if x1 and x2 are normally distributed, then y would also be normally distributed. So we can use a normal distribution to calculate its corresponding probability. So before calculating this probability of a random variable y, we need to know its mean and variance. So as you know, the expected value or mean value of this random variable would be twice of the expected value of x1 plus twice of the expected value of x2. So twice of 2 plus twice of 5, then 14 centimeter is the mean value of the parameter, and the variance of the parameter would be a1 square. A is here 2 square times variance of x, and here in this problem variance of x is 0.1 square. So you got the variance of this linear combination of that random variable, and this would be the mean of that random variable. So and we have seen that individual variance for x1 is 0.1 square, and for x2 is 0.2 square. But the total variance would be 0.2 here. So it means it is not just 0.1 square, or it would be something has increased. That is what you call it, the variance has propagated. Okay, calculating the probability is using the standardized normal distribution. Convert this random variable into z value and calculate the z value from the table to get the probability of the z value, and then convert it into y. That would be the same probability, because area under the curve of the z value would be the same as the area under the curve of the y variable. So here the mean of the y value is 14, and its standard deviation here is square root of variance. So it is a variance, then if you take the square root, it will be the standard deviation of this value. So corresponding to Z, when Y is greater than 14.5, it means Z greater than 1.12. So from the table, we will be able to calculate the probability that 13 point, from the software also we can see that 13.14 is the probability that the perimeter would be exceeding 14.5 centimeters. So this is actually the Z value. So the corresponding value of 1.12 is actually the 14.5. So when y is greater than 14.5, the area under the curve is 13.14 is area under the curve. So that is actually the we have worked out the probability. So here you see when your lengths and widths becomes your random variables, then your parameter, or even if you calculate an area, then it would be square of the x1 and x2. Then your function would be the product of x1 and x2. It would not be a linear combination, but it is actually the square or is the product of the two random variables. And then the resulting distribution for parameter would be different, or even for area would be different, or if we have to calculate volume, so there would be a different distribution for a resulting function. Up to this point, we are only dealing with a linear combination of random variable. Okay, just take another example. Let's say we are actually manufacturing a cricket bat. So cricket bat has two parts. One is the blade, and the other is the handle. So length of the blade is given, and some of the probability of having the length of 38 is, let's say, 0.2. Equal probability and length of 40 centimeter is also probability is 0.2, and 42, 44, 46. So 1, 2, 3, 4, 5 different types of blade lengths are available with you, but the distribution, how the distribution of the length is, let's say it is uniformly distributed. And let's say there is a length of the handles. So handles length would be, there are 3 different types of handles. So there are 5 different types of blades and 3 different types of handles. One handle is 22 centimeter, which probability is 0.3, 24 and 26 centimeter. Okay, so the thing is, the blades and handles can be joined together to make bats of various length, and it may be assumed that the length of the two sections are independent. So it has nothing to do with the length or the distribution of the length of the blade with the length of the handle. So here we can say, or in the we are dealing with two independent variables. One is the length of the blade, other is the length of the handle, and both are uniformly distributed as shown from this probability distribution, and the condition of independent is there. Okay, the first part of this problem is how many different bat lengths are possible. So you have 5 different blades and 3 different lengths. So I would recommend you to take a pause on this video and try to find out how many different lengths are possible. As obviously then in the next part you need to find out you are assuming that the length of the blade is normally is a random variable represented by x1, and you need to calculate the mean and variance of the length of the blade. And in the next part you need to calculate the mean and variance of the length of the handle, which we represent by random variable x2. And then we need to find out the mean and variance of the total length of the bat, which is actually the sum of the length of the blade and the length of the handle. If you add them together, it would be the length of the bat. And in this next part you need to verify this property of dealing with independent random variables. And so the first part is how many different bat lengths are possible. So you have 5 different blade lengths and 3 different handle lengths. So what do you think about how many possible bed lengths are possible. So take a pause and try to answer this. Okay, so we need to look into the possible sample space here. So you see length of the blade is 1, 2, 3, 4, 5 different lengths are possible, and the length of the handle is 3 different lengths are possible. So if 38 plus 22, it would be 60, and 38 plus 24 would be 62, and 38 plus 26 would be 64, because you are summing up the length of the blade with the length of the handle to get the length of the bat. So these would be the possible lengths that are possible. So if you look at there is only one bat would be of total length would be 60, and there is only one bat with length 72. So this would be the minimum length of the bat, and this would be the maximum length, and the two bat would be length 70, 3 would be 68, and 3 would be 66, and 3 would be 64, and 2 would be 62. So 2 beds of length 62, 3 beds for 64, 66, 68, 70, and 1 bed for length 72. So total number of different bed lengths would be 1, 2, 3, 4, 5, 6, and 7. So 7 different bed lengths are possible with that combination. Okay, in the second part, you need to calculate the mean and variance. So as you know the length of the blade and its probability distributions, and you know the formula for expected value of a random variable is, this is x1, and this would be its corresponding probability, p of x, then just multiplying the length with the probability and take the sum. So expected value of this length of the blade would be 42 centimeter, and its variance would be calculated from this alternative formula, and variance comes out to be 8. And similarly we can work out the mean and variance of the length of the handle, which is three combinations we have. So we can calculate its mean value and the variance from the formula. So, and the next thing is to find the mean and variance of the total length of the belt, which is actually the sum of the length. So here the total length would be the sum of x1 and x2. So here as we know there are 7 possible lengths are possible, and probability of getting 60 length is, because it would be 1 by 15. For 72 it is 1 by 15, and because what we have done is multiplying the corresponding probabilities, because 60 is by adding two lengths, length of the blade and the length of the handle. So one is probability 0.2, one is probability 0.3. So then you got this 1 by 5 probability, and then the expected value of the sum of the random variable would be simple. And similarly we can easily see that this property holds, that expected value of the sum of random variable would be the sum of the expected value of both random variables. So we have seen that the expected value for length of the blade is 42 centimeter, and length of the handle was 24 centimeters. So the expected value would be 66 centimeter. So that would be right in the middle, the 66 centimeter. And the variance we can calculate from the formula, and we can verify that both properties hold. So we can see that both properties are holding. And keep in mind here variances are sum of those variances, but because each factor would be 1 square, so 1 square would be 1, and it is being verified. But if there is some factor, then let's say factor is 1 and something is 2, then 1 square would be 1 and 2 square would be 4, then the equation doesn't hold. So keep in mind the properties related to the variance. And it is important to note that even though the variances are satisfied, but the sum of the standard deviations would not be the same, because the square root of each variances would not be the same. So this is the property for variance, not the property for standard deviation. So it is important to realize this. Okay, now let's take another example, which we have a soft drink manufacturer which sells bottles in two sizes. One is a small bottle size 252 ml, other is 1 liter over 1 liter ml, 1012 ml, and their variances for each small bottle and large bottle is given. Okay, in part A, a bottle of each size is selected at random. Find the probability that the large bottle contains less than 4 times the amount in the small bottle. So need to understand this wording. A bottle of each size is selected at random, and we need to find the probability that the large bottle contains less than the 4 times the amount in the small bottle. So each is 252 ml. So you're picking small bottles, and the volume would be less than the 4 times in the small bottle. If in the large bottle, if it is less, that is something you have to work out. Okay, now look at another part, which one large and 4 small bottles are selected at random. Find the probability that the amount in large bottle is less than the total amount in the 4 small bottles. So these two wordings are different, and we will see it how we put in the writing. Okay, the first thing that is given is a small bottle. The volume of the small bottle we represent by a random variable s, and as we know, s is normally distributed with mean value 252 and variance 4. So and similarly, we can represent a large volume of the large bottle with L as a random variable, which is normally distributed with mean and variance 25. In the first part, what is actually mentioned is you need to know the probability that the volume in the large bottle is less than the 4 times of the volume in the small bottle. So you are actually multiplying here 4 times. Times means you are multiplying 4 with the volume of the small bottle. So, and here you are total amount of the 4 small bottles. So you are adding S1, S2, S3, S4. So this is sum of the variables. This is the 4 times of this S. So these two A, B situations are different. Okay, first let's explore the second situation. Is that probability that the volume in the large bottle is less than the sum of the 4 different bottles. So each bottle would be a random variable, and here it is 4 times. So these two parts A and B are mathematically totally different. So this is important to understand, and we will calculate its corresponding probability, because we know the reproductive property of the normal distribution. If the individual random variables are normally distributed, then the linear combination of those random variables would also be normally distributed, and we can use a normal distribution to calculate the corresponding probability. Let's say in the first part, we can say that the probability that the volume in the large bottle is less than the 4 times of the volume in this small bottle, one of the small bottle. So, or we can say that L minus 4S should be less than 0. So this is something we have to work out. So my new random variable would be a linear combination of that would be also a volume, that is the large volume, and 4 times the small volume. So I just need to calculate the probability that my y is less than 0, because y is L minus 4s. So this is something I have to work out. And in order to know y is obviously a linear combination of the normal random variables, then y would also be normally distributed with the mean and variance. So we need to work out the mean and variance of y. So here the mean value of y would be expected value of L minus expected value of 4 times, and then using the property of expected value, and we can calculate the expected value of y. Similarly, we can calculate the variance of the y, which would be 1 square times the variance of L large bottle, which is 25, plus 4 square would be 16 times of the variance of the small bottle, which is 4. Then the variance of the linear combination would be 89 here. Okay, then using this standard normal distribution, just y value is 0 here, 0 minus the mean value is 4 here, and the standard deviation is square root of 89. So we need to calculate the corresponding probability using the table. So this is the first part we have done, and from the software we have seen that 33.58% is the probability. You can use the table as well as because to calculate the corresponding probability, because here mean value is 4 and standard deviation is square root of 89, which is 9.434. So we have calculated this part, or even if you write in terms of Z also, where mean value is 0 and standard deviation is 1, which is a standard normal distribution, then still you got the same area under the curve. It would be representing that 33.58% is the probability that the volume in the large bottle would be less than the 4 times of the small bottle. And keep in mind, here we have used a linear combination, and we have used a property that is actually called as reproductive property of normal distribution. Okay, now look at to this other part of the problem, where the volume of the large bottle would be less than the sum of the 4 bottles, which would be, each bottle would be normally distributed. So S1, S2, S3, S4 would be normally distributed. So you can write like this, or you can say your new random variable would be let's say X, which is L minus this sum of the 4 bottles. So we need to say the probability X is less than 0. So we calculate the first the expected value using the properties of the expected value, and calculate the variance. And you see the variance is actually different in this case. Earlier case we have 89 was the variance, and now you have a smaller variance, that is 41. And now you need to calculate its corresponding probability from this table, and that comes out to be 26.61%. So you see these two problems are quite important, and once you are dealing with multiples of the 4 times of S, or the sum of S1, S2, S3 and S4, you end up with different probabilities. So in using that reproductive property of normal distribution, you must be very careful about, if X is normally distributed, then X1, X2, X3 would be also normally distributed with mean 3 mu and variance 3 sigma square. But if X is normally distributed, and then your linear combination of random variable would be 3 times X, then your new variable would also be normally distributed, but with this mean 3 mu, but different variance. So this is S1, S2, S3, S4 problem, and this is 4 times of S. So if it is a sum of random variables, and if it is a multiple of random variables, their corresponding random variables, which would be a linear combination, would have different distribution, in the sense that distribution is normal, but the variance is different. So this is something you need to take care in dealing with the linear combination of random variables. So if you are making a part which is having x1, x2, x7 dimensions, let's say 7 different dimensions, and each dimension in the manufacturing would be normally distributed, then you have to calculate how much would be the probability of finding a particular area or particular parameter or particular volume. So that would be actually a combination of the random variables. And at this place I stop this lecture.